So in this video, Bruce and I will be showing you how to find the volume of the solid through two different methods. The first method we have is the disk method, which is a little more basic, and the second is the washer method, which is almost a take on the disk method, just a little more to it, and we'll show you that a little later. So here are the equations to find the volumes using each method. First we have the disk method. This shows how volume is equal to pi times the integral of your equation squared. And as you see, we'll write both equations. This works for either dx or dy, depending on the way you're revolving. Next, we go to the washer method, which, as I said earlier, is almost a, oh sorry, here Bruce tells me to darken the V. But as I was saying, this is almost just a little more added to it. It's basically taking two different disk methods and subtracting the smaller one from it to get almost a washer shape for your volume. And again, this works for either dx or dy, but we only show the dx here. You can just replace with y. So now that we have the equation for both methods, here's Bruce to show you the disk method.
So the question starts off with y equals square root of x, limited by 0 to 2, and we are rotating this around the x-axis. So the first step you do is write the volume equation, which will be pi times the integral from 0 to 2 of square root of x squared dx, which equals pi times the integral from 0 to 2 of x dx. The second step you do is you plug that into your calculator and multiply the fractional answer that you get by pi to get an exact answer. Your answer should be 2 pi.
Thank you, Bruce, for that. Now I'm going to show you how to use the washer method. So first we'll start out with a basic problem. We'll start with the equations y equals the square root of x and y equals x squared. So first what we have to do is find out where we integrate this between, and as you see from the graph, these intersect at 1, 1 and 0, 0. So we know on the x-axis we're integrating from 0 to 1. So now we need to write our integral, and we know the volume equals pi times the integral, in this case 0 to 1. And we're going to take the large radius and put it first, so we're going to take the square root of x squared, and subtract the larger radius, and that is x squared, and square that, and then take the whole integral of that, and that comes out to 3 pi over 10. So now we're going to make it a little more challenging. We're going to make you revolve it around the y-axis. So first what we're going to have to do is rewrite the equations. So solve for x, and you'll get x equals y squared and x equals square root of y. And then we'll have to refine the radii. We'll see the new small radius will be x equals y squared, or previously y equals the square root of x. We'll see the new large one is x equals the square root of y. So now to find the volume, we'll set up our equation. So v equals pi times the integral, and we have our large radius, and subtract the small radius, square both, take the integral, and that will also coincidentally come out to 3 pi over 10. This will not always happen though, so you have to be careful. So now we'll continue to make it just a little more challenging. What we're going to do is revolve this around y equals 2. So instead of just having it around it'll be around another horizontal line, but instead of it being the x-axis, we'll have it around a separate line floating the graph. So here we see it'll be the same graph, and then we'll have what we're rotating around at x, or y equals 2. And so again, we need to find which is our small radius and which is our large radius. The reason that y equals the square root of x is a small radius is because, again, it is physically closer, therefore that will be a smaller distance, therefore a smaller radius. So now writing this equation for the volume will be a little more tricky, because now we have to factor in that we have changed the graph. We're now treating I know I said before it wasn't, but we're treating y equals 2 as an axis, so we have to change the graph to be from there. So you see, now we've changed x squared to x squared minus 2 to account for that change. So the volume will equal pi times the integral of x squared minus 2 squared minus small radius squared root of x minus 2 squared. Or you could write it as 2 minus your graph, which either way works. Because you're squaring it, it'll come out to be the same answer either way. So there they are, and you can either pause at this moment to look over it, or you can keep going. That will come out after plugging into your calculator, and obviously you put in the pi, it'll come out to 31 pi over 30. So now the last thing we can really do with this, probably the most challenging just because your numbers can get mixed up, will revolve around a floating vertical line, not the y-axis. So I believe, yeah. So we will rotate it around x equals 3. And this is just so it won't be the same answer like we got before. It'll be something a little different. So first we're going to have to draw the graph. Same graph as always. It'll be those two plus the x equals 3 to see what we're rotating around. Relocate, which is the small radius and which is the large radius. In this case, finally again, the large radius will be the y equals the square root of x, and the small radius will be y equals x squared, as you see there. And again, since we are doing this around the y-axis, we have to rewrite those equations for x. So x will equal y squared again, and x will equal the square root of y. Now again, we write our volume equation. The volume will equal pi times the integral. Again, 0 to 1, same intersections. And this time, since the large radius was y equals square root of x, it'll be x equals y squared. But again, you have to account for that change in the line you're rotating around, so you have to either subtract 3 or subtract it from 3. We'll show both. Square it and then subtract the smaller radius, square that, and take the whole integral. And that'll get you there. I'll take this little bit of downtime to apologize for any errors I made and erase. I know in an upcoming problem I made a few. I'll try to blur them out as best as I can. So as I'm wrapping up here, you can see the very subtle differences in the equal equations, both after plugging into your calculator and multiplying through by the pi to get an exact answer, you'll get 17 pi over 10. And that'll do it for the washer method. So up next, we will walk you through a word problem. So now for the word problem, we will be finding the volume of a sphere with a radius of 5 inches after a manufacturer drills a hole into that sphere with a radius of 3 inches. So what we're going to do first is just highlight or underline the important information. Get rid of the rest, it doesn't really matter. So we see that the sphere with radius of 5 inches will come out for an equation to be y equals the square root of 25 minus x squared. And then for the hole's radius, it'll just be y equals 3. It will not be another circle because we're not hollowing it out, we're drilling a hole straight through the side. And this hole will still be circular because we are obviously rotating it around the axis. So I apologize in a little advance. I messed up a little bit on this. So I should have drawn, for what I was doing, I should have drawn just the quarter in the first quadrant, because as you see in my integral, I'll give volume equals 4 pi times the integral from 0 to 5, which will just be that 1/4, the radius of the large radius minus the small radius, which would be the drilled hole, and that'll come out to 230 pi over 3. So hopefully this helped, and if you have any further questions, I understand that this video could have been confusing throughout the entirety. So if you have any further questions, either ask Bruce or me, and we'd be happy to help.